So I showed how I changed the generate children by using the size. Then I showed how may you can do display path by using size. So this is my display path. Then for the heuristic function, I give one hint. You can use a Manhattan distance. Then you're gonna think about the distance between two positions, goals character and your state. So goals 1 will be at 0, 1, and you need to find where is the character 1 in state. Then you're gonna calculate row and column, then find the distance between those two. When you get the row number, you can do integer division. When you get the column number, you can use a reminder, modular. Then Fs means absolute values. When you calculate distance, it's good. You can square it, or you can just get the absolute value. It's your choice. And after, you can also combine multiple heuristic, like a misplaced heuristic, distance heuristic. Some people combined those two. Or some people used something like a scale factor for the distance heuristic. It is also good. So for a hint about this, then I just copied my heap priority queue into the code. Actually, I expanded this one from the puzzle. Then after I copy all the method, I probably will use just a pop and heap up. Heap down is a pop and push. And heap down is a recursive method because when I use iterative, it's too long. Then heap up method, I use the iterative way because it's faster than recursive. Now, in my A star, I didn't do something special. I just did, like a frontier has now tuple. So whenever I push it to my frontier, I have three things like I showed in the example, the date4 note. My frontier is a heap priority queue. It means it never empty. So when I want to check if a frontier is empty or not, I use the isEmpty method of frontier, which is defined in the heap priority queue. I usually explore it for two reasons. One is to check if the node is already explored or not. And the second reason was keeping the shortest cost, lowest cost. So whenever I calculate the total cost, heuristic plus the path cost, if the cost is smaller than I already explored, I update it to the new cost. So keep up the shortest one. Then whenever I push into the frontier, previous path plus new item, the child will be added in the list. So basically same as my BFS. The frontier explored, then while frontier is not empty, pop it, check the goal test, then generate child. Only one thing is using the heuristic, estimated the total cost, then update lowest cost, then update frontier and explored. That's it. Then when I use this, there were 4 test cases. So without using any techniques for the speed up, you can also do speed up. Before speed up, first case, timing. Second case, which is the 16 length, it also 0.012, it's not bad. Then third case, because this one does not have any speed up thing to scale, so it's time, but still like around 1 second, not really bad. Then fourth one takes long, but it does not test my patience. It is done less than 3 seconds. reachable. It's not really painful without doing any specific technique. Just the basic technique gives me good timing. So if you do not have a good timing in your code, you can think about you are wasting some time in a small task, not in the big task. So I look at my heap article again if it's written efficiently. If I do not do any redundant for loop. Whenever you add one more for loop inside of the code, it becomes like a big O n cube or big O n square. So whenever you add one more degree, your code will become much slower.